Hello friends, we will continue the series of concepts through the questions. So today's question is on screen. So the question is a block which is 14 to 20 into 10 centimeter, which is weight of 160 Newton, is moving at constant velocity, which is 1 meter per second, on an inclined surface which has coefficient of friction is 0.25. Now we have to find the force F applied in horizontal direction, and in second case, if we apply a oil of thickness 0.3 mm, then what will be the force required? And we have also calculated the percentage reduction in force. So we take the first case. So in first case, we have to consider the friction. So block is moving upward, so friction is downward. So this is F of F. Weight is 160 Newton, and the normal of it, which is Fn1. The weight has two components. One is along the surface and another is perpendicular to the surface. So perpendicular to the surface, which is 160 cos 20, because this one is 20, and this is the 160 sin 20. Now we balance the force along the inclined surface. So balancing the force along the inclined surface. So we have to resolve the F in along the inclination and perpendicular to the inclination. So in first case we consider F1. So if we resolve it, so along the inclination, so this is the F1. If this is 20, this is F1 cos 20, and this is F1 sin 20. This is the F1 sin 20. Now we write down the equation along the surface. So this is F1 cos 20 minus F of F, that is friction force, minus 160 sin 20 is equal to the 0. So this is 0.93 of F1. This is F of Fn1, that is friction coefficient into normal force, is equal to the 54.72. So again this is 0.923 F1 minus 0.25 of Fn1 is equal to the 54.72. So this is the equation number 1. Now balancing the force along the perpendicular to the surface, that is balancing the force perpendicular to the surface. So that is in this direction. Now this is the Fn1 minus F1 sine 20 minus 160 cos 20. So this is the 0.34 F1 plus Fn1 is equal to the 150.35. So this is the equation number 2. So these are linear equation with two variables. So if we solve it by solving equation 1 and 2, we get F1 is equal to the 109.23 Newton and normal force Fn1 which is the 187.5 Newton. Now our first part is solved, that is we have to determine the force when there is a friction. So the second part, in second part we consider there is a oil film. So oil film in between surface and block. Now if we draw the FBD, so there is a oil film and this is the block. So there is a oil film, so there is a shear stress, and due to shear stress there is a shear force which is in this direction. This is the shear force. This is weight is 20, so this is 160 cos 20. This is the 160 sin 20, and it's moved with velocity of 1 meter per second. Then this is Fn2, that is normal component, and a force, horizontal force, which is say F2. It has two components, along the surface and perpendicular to the surface. So this is the F2 cos 20, and this one is F2 sin 20. The oil film thickness, which is given as 0.3 mm, and the viscosity, which is 0.012 Pascal per second. So we need the shear force due to the oil film. The shear force, which is the shear stress into area. And so this is mu times V into H. So if you consider the linear profile of between the block and surface due to very thin layer, so we can consider it as linear. And area, so again the shear force, which is the 0.12 to velocity is 1 meter per second, clearance or the film thickness, which is 0.3 into 10 to the power minus 3, area, which is 0.4 into 0.2. So this comes out to be 3.2 Newton. Now we repeat the previous concept, that is balancing the force along the surface and perpendicular to the surface. Balancing the force along the surface. This is the F2 cos 20 minus shear force minus 160 sin 20 is equal to 0. From here we get F2 is equal to the 61.64 Newton. So this is the force in shear. The second case, when there is a oil film applied between the surface and the block. Now the percentage reduction in force, percentage reduction in the force. So this is the F1 minus F2 divided by F1. This is the F1 is 109.23 minus 61.64 divided by 109.23 into 100. So this is 43.56%. This is the reduction in force when there is a oil film applied between the surface and block. Thank you.